Okay, here are the Mod 14 Part 2 notes. This is page 3. We are going to add in a couple of things, and we are going to change up just a little. We are going to eliminate that. Okay, so this time we have a data set. And we've done this before. So in Excel, what I did was enter all of this information into a column. So we're going to use this information to find X bar. In Excel, we type equal average, parenthesis, and then it's my first number, colon, to the last number. Now you can just click and drag. We get an X bar, a sample mean of 36.8. Sorry, I guess I should have read the question. So we have a website called fueleconomy.gov, which allows drivers to report the miles per gallon of their vehicle. So we've got a random sample of 16 Chevy Impalas. The mileage and the miles per gallon are reported and in the table below. We want a 99% confidence interval for the mean gas mileage of all Chevy Impalas. So we want an average gas mileage. So we're using the average gas mileage from this sample, this 36.8. Standard deviation here, STDEV dot S. This is a sample. So S for sample, P for population. We are using the information from a sample. And I get 2.92. I have an N of 16. There's 16 values in the table. So my degrees of freedom, 16 minus 1 is 15. Okay, now. We've got a confidence interval of 99%, which means my alpha is the other 1%. So, fun fact, Excel is updating all of the time. And there is a command I'm going to change up, and I'm not going to re-record page 2, but we are going to change up here a minute, and we're going to write this in hot pink so it's obvious. If you start typing T dot inverse, you notice there's a T dot inverse dot 2T. That means two tail. So what that's going to do is it's going to take the probability. So 0.01, I don't even need to cut it in half. Here's my degree of freedom, 15. And rounded to two places, we get a 2.95. You need to understand that that is the 0.01 is the area in both tails. So it's still going to be 0.005 in each tail, but this just gives you a different way to look at it. So here's how we find the confidence interval. We have X bar plus or minus. I'm still writing this as T of alpha over 2. It is still the area in one tail times S divided by the square root of N. We have 36.8 plus or minus my 2.95 from above times my standard deviation is 2.92 over the square root of 16, which actually is 4. 3.68 minus 2.95 times 2.92 over 4 gives me a 34.6. When I add, I get a 39.02. So we are 99% confident. that the average gas mileage for a Chevy Impala is between 34.6 and 39. I guess I should round to the same on both, 39.0. Think we can cram that in here? I'm just going to write it really small. We are 99% confident that the average gas mileage of a Chevy Impala is between 34.6 and 39 miles per gallon. Example 5 at the CCD New Student Orientation, a statistics student was told that students are supposed to spend 2 hours working outside of class for every hour in class. Actually, that's 2 to 3. She selected a representative sample of 100 CCD students. So our N is 100. And asked them, how many hours of schoolwork do you do outside of class for each hour in class? The mean for the 100 responses was 1.2 hours. Our standard deviation, and this feels a little weird, we're not used to having a standard deviation that's bigger than the average, but that's okay. We want a 95% confidence interval. So 95%. If n equals 100, our degree of freedom is 99. Super excited here. T dot inverse dot two tail. See if it's a 95% confidence interval. That means my alpha is the other 5%, 0.05. 99 degrees freedom. And I get 1.98. Notice it gives us the positive, understanding that in the formula, it doesn't really matter. So we have x bar plus or minus t of alpha over 2 times s over the square root of n, 1.2 plus or minus 1.98 times 2.3 over the square root of 100 is 10, so I'm just going to write that in there. When I subtract from 1.2, I get 0.7446, so 0.74. When I add, I get 1.66. So just a reminder, this is 1.2 minus 1.98 times 2.3 divided by 10. This is 1.2 plus 1.98. So to interpret that confidence interval, we are 95% confident that the mean number of hours students spend outside of class for each hour in class is between 0.74 and 1.66 hours. Still below the 2-hour recommendation.